Hi folks, so welcome to the lecture where we have a look at solving simultaneous equations using substitution. Now, in order to solve a linear equation, there must only be one unknown variable, okay? That's just the general rule to solve a linear equation. In the substitution method, what we do is basically one or both of the equations have to be in the form where one of the two variables is the subject. So for example, if the two linear equations we're looking at is y equals x plus 4 and 4x plus y equals negative 5, we know that this one already is in the right form because in this one, y is actually equal to another expression. So we need that to happen. So in this case, what we do is we would take equation 1, which is in the correct form where y is the subject. So this variable, y in this case, is substituted into equation 2. So we take y equals x plus 4. So since y is equal to x plus 4, we simply substitute it where y appears on the other equation. So it becomes 4x plus x plus 4, okay, where the third equation is produced. So we have 4x plus x plus 4, which is equal to negative 5. So once again, guys, all we have basically done is taken that y equals x plus 4, because y is the same as x plus 4, and simply replaced it with the y in the second equation. So where y came up in the second equation, we simply replaced it with an x plus 4. And then, now, since we are reduced down to the single variable, we can solve it using our general algebraic skills, okay? Now, this equation is then used to solve for x. Once x is calculated, it is then substituted back into equations 1 or 2, doesn't matter which one, and we find the y. Now, if you have found the x value correctly, you will find the same y value using either equation. That's the best part. Okay, so if we have done all the steps correctly and we find the correct x value, we can substitute it into the first equation or the second, and we'll get the actual same answer. Okay, so let's put this into the action. Okay, so this question says, solve the following simultaneous equations using the substitution method. Okay, so let's write out the first one. The first one is y equals 2x minus 11, and that's equation 1. Then we have y is equal to 4x plus 1, which is equation 2. Okay? All we have to do is simply substitute this into that, or this one into this one. Okay? Now y is equal to 2x minus 11 as well as 4x plus 1. So let's say we substitute equation 1 into, okay, equation 2, okay? What that means is we are replacing, let me use a different color, we are replacing this y, okay, because we are substituting 1 into 2, we're replacing that y with 2x minus 11. So that gives me 2x minus 11, now back to my original color, equals 4x plus 1, okay? We've simply replaced this y with the 2x minus 11 there. Now we have to solve for it. So let's take the plus 1 to this side, and at the same time, let's take the 2x over to this side. So we have minus 11 minus 1 equals 4x minus 2x, okay? So minus 11 minus 1 is negative 12, is equal to 4x minus 2x is 2x. And that gives me x is equal to negative 6. Very good, okay? Now we can substitute that x equals negative 6 back into either equation, 1 or 2, we should get the same answer. So let's test that out. So we have y is equal to 2x minus 11, so that's 2 times negative 6 minus 11. So negative 12 minus 11 gives me negative 23. Okay, let's test it out with the second one as well. So we have y equals 4x plus 1, so 4 times negative 6 plus 1. So negative 24 plus 1 gives me negative 23. Oops, 23. So once again, it's a tick. So our intersection point for these two particular equations are negative 6 for the x and negative 23 for the y. So that right there is our answer. Alrighty, let's move to part B now. Alrighty, so we have y equals 3x plus 8 and y equals 7x minus 12. Okay, so once again, let's substitute, okay, now let me use a different color. Substitute this y with this y here, because remember y, they're the same y, they're both equal to two different things, so we can equate them to each other. So substitute equation 1 into equation 2, okay? So that means it gets replaced with, using a different color, 3x plus 8 equals, okay, 7x minus 12. So once again, using our normal algebraic skills, so we take 3x to this side, and we take minus 12 to this side. So that gives me 7x minus 3x, which is equal to 8 plus 12. 7x minus 3x is 4x, and 8 plus 12 is 20, which gives me x is equal to 5. Now, substituting x equals 5 into either of these two equations, that becomes y is equal to 3 times x, which is 5 that we just found, plus 8, okay? Which gives me 5 times 3 is 15, plus 8 is 23. Now, testing it with the second equation as well, so y equals 7 times 5 this time, so 7 times 5 minus 12, so 35 minus 12 is also 23. So once again, you don't have to do this every time, guys, but I'm just showing you that if you find the x value accurately, then we can replace it into either of the two equations and we should find the correct y value. Okay, so our intersection point in this case is positive 5 for the x and 23 for the y. That right there is our answer. Okay, let's have a go at part C now. All right, part C, we have y equals 2x minus 10 and y equals negative 3x. So 2x minus 10 is equation 1, y equals negative 3x is equation 2. So once again, same concept, substitute equation 1 into equation 2. So what that means is we're replacing this with that, okay? With that. Okay, so we have 2x minus 10 is equal to, negative 3x. Then, taking 2x to the other side, we have negative 10 is equal to minus 3x minus 2x. So negative 10 equals minus 5x. Taking negative 5 to the other side, we have x is equal to negative 10 divided by negative 5, which is positive 2. Then, substituting x equals 2 into either of those two equations, I want to put it into y equals negative 3x. So y is equal to negative 3 times 2, which is equal to negative 6. So our intersection point for these two particular equations are 2 and negative 6. So that right there is our intersection point. Fantastic. So folks, now I hope you were able to get the same answer if you did happen to pause the video and have a go at the question yourself. Next, we'll have a look at the next set of questions. Okay, so we have solved the following simultaneous equations, once again using the substitution method. Okay, so let's try that. So we have a is equal to x equals negative 10 plus 4y. Let's call that equation 1. And we have 3x plus 5y is equal to 21. Let's call that equation 2. So same concept. We have it equal to x this time. All right, so let's substitute equation 1 into equation 2. Okay, so if I was to use a different color here, that x is going to be replaced with negative 10 plus 4y. Okay, so let's do that substitution. So we have 3. Now x gets replaced with negative 10 plus 4y, as we just said. All right, then we have plus 5y is equal to 21. Expanding this bracket out, now we know the distributive law, so we just expand that out. So we have 3 times negative 10, which is negative 30. 3 times 4y, which is 12y, plus 5y equals 21. Taking this over to this side, we have 12y plus 5y, which is 17y on the left-hand side, and we have 21 plus 30, which is 51. Taking the 17 to the other side, we have y is equal to 51 divided by 17, which is equal to 3. Then we can plug that value of 3 back into equation 1 in this case, or equation 2, doesn't really matter. Equation 1 is a little bit easier because it's already x equals. So x equals negative 10 plus 4 times 3, which is 4 times y, and we have negative 10 plus 4 times 3 is 12, and negative 10 times plus 12 is simply 2. So our intersection point for the first two graphs are 2 and 3. There you have it. And one way you can double check the answer is to substitute 2, 3 back into either equation and see if you're getting the right answer. Beautiful. Let's have a go at part B now. Okay, so again, we have 3x plus 4y equals 2, which is, I've called it equation 1. And we have x equals 7 plus 5y, which is equation 2. So let's substitute equation 2 this time, okay, because we already have it in terms of the x, so the x is the subject already, into equation 1, okay? So we're substituting that where that is, okay? We're simply replacing the 2. So we have 3 in place of the x, we have 7 plus 5y plus 4y is equal to 2. Expanding this out, we have 3 times 7, which is 21, plus 3 times 5y, which is 15y, plus 4y is equal to 2. Taking 21 over to the other side, we have 2 minus 21, so 15y plus 4y gives me 19y, and 2 minus 21 gives me negative 19. Taking 19 to the other side, it becomes y is equal to negative 19 divided by 19, which gives me negative 1. Then if I was to substitute y equals negative 1, I'm writing this out this time, in negative 1 into equation 2, we would have x is equal to 7 plus 5 times negative 1, which becomes 7 minus 5, which is equal to 2. So our intersection point in this case is 2 and negative 1. As you can see, guys, it's a fairly straightforward method to actually solve simultaneous equations using substitution. So if you're feeling comfortable at this point, please pause the video and let's have a go at parts C, D, and E by yourself and see how you go. Alright, so 3x plus y equals 7 is equation 1. X is equal to minus 3y is equation 2. So once again, substitute equation 2 into equation 1, okay? So that part there gets replaced with this here. So we have 3 minus 3y plus y is equal to 7, okay? Then expanding this out using our distributive law, so we have 3 times negative 3, which is negative 9, 3 times negative 3y, which is negative 9y, plus y is equal to 7. Then, taking minus 9 over to the other side, we have 7 plus 9 on this side, so 7 plus 9 there, and we have negative 9y plus y here, which is negative 8y. So negative 8y equals 16, gives me y is equal to negative 2. Excellent. Now substituting y is equal to negative 2 into equation 2 gives me x equals negative 3 minus 3 times negative 2, which is negative 3. Negative 3 times negative 2 is plus 6, which gives me positive 3. So our intersection point in this case is 3 and negative 2. Were you able to get the same answer if you had the opportunity to have a go at the question yourself? Okay, let's move straight into part D now. Okay, so we have 3x plus 2y equals 33, equation 1. Y equals 41 minus 5x as equation 2. So we have substitute equation 2 into equation 1. So this replaces this. So 3 bracket 41 minus 5x plus 2y is equal to 33. Okay, now let's expand this out. So we have 3 times 41, which we know gives us, whoops, I just realized I made a mistake because I'm replacing the x instead of the y. So let's cross this off. Let's start again. So we have 3x, so it's actually the y. So I just got a bit caught up because we've been dealing with x's so far. So it's the y that actually replaces this bit here, okay? So we have 3x plus 2 in bracket 41 minus 5x, which gives me, and then that equals 33. Apologies for that. Okay, now let's expand this out now. So we have 3x plus 2 times 41 is 82, minus 5x, or 2 times minus 5x is negative 10x, equals 33. 3x minus 10x gives me negative 7x, equals, then you take 82 over to the other side, it becomes 33 minus 82, which gives me negative 49. Then x is equal to negative 49 divided by negative 7, which gives me positive 7. Then substituting x equals 7 into equation 2 here. So that gives me y is equal to 41 minus 5 times 7. So 41 minus 35 basically, which gives me 6. So our intersection point in this case is 7 and 6. So the little blunder that I made at this point here, guys, would have really cost me because I would have ended up getting completely the wrong answer and I wouldn't have been any wiser. So I'll just encourage you to be a little bit careful when you're working with them and just maybe even double check your answer. So say you did get to the final point, you get 7, 6. I will double check that answer by substituting it back into these equations here to see if you've got them correct. Okay? Fantastic. Now for part E, I want you to again pause the video and have a go at the question yourself, and we'll come back to it in a couple of seconds. Alrighty, so we have y equals 3x minus 3 as equation 1, and minus 5x plus 3y equals 3 as equation 2. So substituting equation 1 into equation 2. So I'm replacing that bit with this term here. So that gives me minus 5x plus 3 bracket 3x minus 3, because that y got replaced with 3x minus 3, which is equal to 3. So we have minus 5x, 3 times 3x, which gives me plus 9x, and then 3 times negative 3, which gives me minus 9, equals 3. Minus 5x plus 9x gives me 4x, and taking 9 over to the other side becomes 3 plus 9, which is equal to 12. So x in this case is 12 divided by 4, which is 3. Then substituting x equals 3 back into equation 1 gives me y is equal to 3 times 3, okay, and then minus 3. So that becomes 9 take away 3, which gives me 6. So the intersection point for these two equations are 3 for the x, 6 for the y. So 3, 6 is the right intersection point. So folks, that's how we solve simultaneous equations to find that intersection point using the substitution method. Really hope that was helpful. As you saw, I made a mistake, while I was doing the working out in part D. Those kind of mistakes are quite common, but I do implore you to be a little bit careful and make sure that you check your answer at the end to ensure that you have in fact done the calculations correctly. Okay, so I hope that was helpful, guys, and make sure you have a go at the worksheets, and I will see you in the next lecture. Thanks, guys.